Cool.
Yep.
So hi, my name is Advi. Today I'll be presenting OptiHome. So, so let's just jump into what I'll be talking about. We'll be covering first the idea of having an even smarter home, getting into what OptiHome is, talking about what its algorithm would be like, then talking about how you'd set it up, looking at a prototype, its features, before wrapping up today's presentation. So let's first start off with the idea of an even smarter home. Right now, smart homes are becoming, frankly, very widespread, but AI also has the potential to make these smart homes even better. Right now, we do have smart thermostats that are constantly synchronized with our network and our phones, but if we had AI interact with it, then we could have convenient and automated, transparent um, access to ways to automate your home. In addition, thanks to AI technology being able to adapt to your surroundings, it would become personalized and better able to adapt because nobody wants AI technology that won't be able to understand how you work and instead it'll just go around randomly changing your HVAC system and other parts of your home. So these AI has the potential to help busy homeowners and disabled people who oftentimes don't have the ability to go around managing their household. Right now, HVAC systems already used up 19% of our total household usage. And if anything, right now we're looking at more smart thermostats than ever before. So we have the potential to make a big difference. Lights and appliances are also a big user of energy. So if we can shut these off immediately after use, you could save a lot of energy, but obviously that's not feasible for all of us. So that brings us to OptiHome, which is an AI-based smart home management system cameras and infrared trackers for opening doors, which are already available in your smart homes to create a computer vision network that tracks the occupants of the household with individual user profiles. The system is capable of noticing things like activities, whether a user is awake or sleeping, and also the habits of every user in the household. Let's talk about some of the data inputs. Right now we have I'm looking at HVAC use patterns, like how people would prefer to use their cooling, what temperatures they prefer, routine user locations throughout their household, peak usage times, user status, like if they're awake or sleeping, as I mentioned before, energy usage trends, as well as pattern-based estimations for when people are leaving, like if they're leaving for work, among other things. Computer vision is going to be one of the biggest key factors that make OptiHome work because it's going to be able to essentially track where everyone is throughout the household and adapt accordingly. So here we'll have a quick diagram that just demonstrates what an AI smart home system would fundamentally work like. As I mentioned, you'll have a lot of sensor data that essentially keeps track of where people are in the household and how they're using their appliances that are being plugged into smart home apps. Right now, we already have this data that's widely accessible to use, and thanks to APIs, these are able to be sent to other apps like OptiHome, where AI models can essentially use these data sets and learn about user behavior patterns and their preferences. From there, it's fed into OptiHome, and eventually OptiHome takes control of the smart home apps based on the settings that the user says that they want to prefer. So eventually, it'll be interacting with things like HVAC systems, lights, your smart appliances, and also notifying you about any open doors or windows throughout your household. So let's talk a little bit about the algorithm design. Raw data, as you expect, would be fed into a reinforcement learning algorithm. There are going to be separate algorithms for every household function, like your HVAC system would have a separate algorithm from your smart appliances that would manage your overall energy output. And okay, this is where AI becomes one of the most confusing parts to a lot of users. People don't want to spend all their time looking at apps and adjusting settings or having to constantly spend time on their phone when they could be managing their own business. And so the beauty of OptiHome is that it's mostly automated, and because it's very difficult to describe to users, the app is going to be designed such that users will be conveniently able to turn features on and off, and they'll also be notified if they want to while the algorithm is adjusting home settings. In terms of the setup, users are going to initially set up their own preferences, for example, automatically minimizing HVAC use, their notifications for allergens in the air, among other things. the reinforcement learning is going to have the algorithm is going to have a 2 week period where there's going to be no action that's going to be taken, and it'll just learn how the user's routines go, and based on that, it'll start interacting afterwards. The policy is intended to be easily viewable throughout the standalone app, as I mentioned before. For example, if the HVAC system is under the control, the user can opt into a notification that'll tell the user, for example, if the HVAC is being set to 79 degrees, for example. It'll also integrate seamlessly with existing smart home APIs like Nest, Google Home, and Matter, which thankfully already have all of this data widespread and easily available to access. So this was just a quick demo of what I would imagine this app to look like if you were to have OptiHome functioning in your home. It would be, as I mentioned before, very transparent and easily accessible if you want to change your settings. For example, saving energy when the home is empty would be as simple as flicking a switch on and off. And obviously, nobody wants their algorithm to be making changes without their permission. So this is one of the most critical parts where the algorithm will be transparent about what action it's taking, and it'll tell you, and you'll know, and you'll be in full control of what the algorithm is doing. In addition, it'll also keep track of activities and habits, as I mentioned earlier. The computer vision algorithm will be tracking individuals throughout the house and accordingly adapting your HVAC system and other smart home appliances. For example, if you have an empty house, it'll shut down the HVAC until automatically turning it back on around the expected return times. So you could save a lot of energy without having to go through the hassle of shutting down each of your HVAC systems individually. Additionally, it'll also adjust your HVAC based on how many people are present throughout your household and present in a room, because sometimes it's just inconvenient to get to those things. It'll be able to differentiate between weekdays, weekends, and holidays because um, obviously your schedule depends on on each of your uh, overall schedules. So if it's a weekday, chances are you're going to be out for work, and accordingly, it'll be able to compensate. In addition, during nighttime, it will be compensating for saving more energy. For example, if people are sleeping in a room, lights will only reach a maximum dim brightness because you don't want to disturb the people sleeping in that room. And lights will also automatically turn on. No need to use manual switches. This is especially useful. I know my grandparents at home struggle to see at night, and oftentimes they have to get around the house at night, and so things like this automatically turning on the light using computer vision are a massive quality of life improvement, which people did not have before. And it definitely saves a lot of energy using lights only when you need them to be used. Environment compensation, on that, we have allergy season compensation. For example, it'll notify users about open windows because environment pollutant data is openly accessible. It'll be able to notify the users about these. Also, it'll increase HVAC use to filter out more clean air if the user does indicate that they have allergies. And it'll also have seasonal energy savings, obviously prompting the user to open windows if it is more comfortable and more energy efficient to do so. So at the end of the day, we're looking at an AI algorithm that is designed to seamlessly integrate with existing smart home hardware and software. It creates an IoT network that feeds data to the algorithm. Reinforcement learning algorithms will adapt to user patterns that are transparently available to be shut on and off at the user's will. And ultimately, you're looking at more automated smart homes that maximize energy efficiency, which is convenient for everyone. All right. Do we have any questions?
Cool. Yeah, I just wanted to ask you